Okay, welcome everybody. Today's session we're going to talk about LANs, which is part 2 of yesterday's session that I didn't get to finish. So that's what we're going to talk about right now. So for some of you who actually attended the lecture on Tuesday the 27th of May, I forgot to hit the record button, so it actually meant that I had to redo this session, which is what I'm doing now. Okay, so let's start. I'm going to jump straight down to slide 24, okay, where we're going to talk about LANs. So, simply stated, a network is two or more computers that exchange data. A LAN, a local area network, is a group of these computers that are confined to a small geographical area, usually one building. Setting up a LAN requires computers with network adapters, centrally connecting devices to connect those computers together. And what they do is they use a numbering scheme called IP addresses. What the scheme does is it gives every unique device on the network an individual IP address. And that's how you differentiate between one device and another within a network, is by the IP address. Okay, so setup might also include servers, some type of protective devices, for example firewall, and connections to perimeter networks that might be adjacent to the LAN. Okay, so reasons why organizations would use LANs, okay, for sharing information. Okay, the networks allow the sharing of files, databases, and media. For communication purposes, okay, networks are critical for email, instant messages, and fax capabilities. Organizations, networks centralize data to make it more accessible for everybody, especially if it's a global organization and people traveling around the globe, that they can access the information efficiently and with speed because it's all accessed in the from the one area. Okay, money. A network should ultimately save a company money, often by aiding in the budgeting process and or increasing productivity. Okay. So let's talk about the structure of a LAN. Okay, so what I want to get you to do is to think about your LAN setup at home or at work and to draw it down on paper. Get a pen, get a paper, and draw it down how you think it's set up at home, how you have it wired or wirelessly connected. Think about the physical connection of the computers, the logical connections of the various IP addresses that are involved. I just want to also mention to you there's software called Microsoft Visio 2010, okay, and that can be downloaded. I have a link in Course Essentials that you can download it. It's in under software downloads in Course Essentials on Moodle. So you can just do a Google search for it. And what it is it's actually software that you use to draw network diagrams. So one thing I'm just saying here in the bold here is that it's actually important as a network administrator to be able to draw diagrams down on paper before you actually implement them. Before you physically go and connect your servers, your laptops, your routers, your switches, hubs, whatever it is, before you do any of that networking, you need to be able to write it down on paper, and it's a skill to write it down and figure it out on paper before you implement it. So for some of you who might not have completed assignment 4, just a helpful tip that some students have done is when they've downloaded the software, you watch a video for assignment 4 and then you detail the structure of that network. So that might be just a helpful tool that you can use for that. Okay? And if by chance you already have submitted assignment 4 and you would like to do it again, okay, that's no problem. You can. Okay. So let's look at a basic LAN. Okay, so in reference to your book, I'm actually on page 3, okay, talking about your basic LAN. Okay, so here you will notice that there's a hub, okay, that's connected to a server, a laptop, a Mac computer, and another PC, okay, and these are all connected to the center by a hub, okay. This is really the most basic central connecting device that you'll ever use, where it connects to each computer, and all these devices that are attached to the hub are known as hosts, and the way that they are connected up is by copper-based cabling. Any host that sends data must first send the data to the hub, where it is amplified and broadcasted to the rest of the network. Okay, so the data comes into the hub, and the hub, what it does is it amplifies all this data and it sends it out to the devices on it. Okay. Broadcasting means that the data is sent to every host on the network, and the only intended recipient receives the data. Okay, so the rest of the devices that do not want the data or it's not intended for do not accept it. So, for example, the data is sent out to the MAC address or to the Mac PC, and it's sent to the laptop, but none of them want it. It's the PC that's waiting on this piece of data. So what happens is both of those reject it and the PC accepts the data. Okay. All right. So really that's what you have. You have a server that is used to centralize the data and to share it or to serve it to other computers on the network. You've got a regular PC here that usually acts as a client on the network, most likely getting its information from the server. Okay, and obviously with the PC you can also store information locally. With the Mac, okay, it's just another client computer, and a Mac can store information locally and also get it from the server. Okay, and the laptop, this could be a Mac or a PC, doesn't matter. Despite its portability, a laptop stores and accesses data the same way that the other two computers do. Okay. Now, so let's look at an intermediate LAN. Okay. So with an intermediate LAN, what we have is we basically replace the hub, which is on the basic LAN setup. We replace the hub with a router. Okay, and this router has 4 ports on it. These are called SOHO, which is small office home routers. Okay, so some of you might already have these at home. So it allows you, it's 4 ports, so it allows you to connect 4 devices to it. Okay, the router acts as a central connecting device with special communication links to the internet. Okay, so here you have the router that's connected out to the internet. Okay, this communication link here between the router and the internet is where the LAN ends. So once the router accesses or moves out onto the internet or onto the World Wide Web, right there and then that is the cutoff point where the LAN is it's no longer part of the LAN. Okay, so the PC, the server, the laptop and the router are all within the LAN setup. Okay, beyond this is outside the LAN. Okay, so you can just take reference there to page 4 in your book, okay, which is where this I've taken this picture from. Okay, so you can actually also use Visio, as I said, if you want to kind of draw down the diagram and get an idea of what it looks like of your own configuration at home. Okay, so now let's look at an advanced LAN. Okay, so an advanced LAN, obviously, as the word says, it's more advanced. It's got more devices, more configuration, more switches, more hubs set up to it because it's serving as a bigger network setup in relation to intermediate and basic LANs. Okay, so what we have is we have added more central connecting devices. Okay, so instead of connecting hundreds of devices to a central single connecting device, so here, okay, what we've done is we've broken up the network into a hierarchy fashion. Okay, for example, on the left hand side here, okay, there are two PCs and one server that are all connecting into a hub. Okay, so let's say, for example, that this computer here represents 24 computers, and this computer here also represents 24 computers. Okay, and these are all connected into the hub. Okay, instead of connecting all of the computers to a single central connecting device, which might not be physically able, okay, depending on what the device can actually host or support, we have connected the groups of 24 hosts to their own hub. Okay, so each of these here are seen as hubs. So we have connected 24 computers, okay, in here to this hub. Okay, so I guess if you count it up, maybe that might be a bit misleading. What I might do is just take this out. Okay, Actually, we'll just say there's 24 computers in total that is connected to this hub, okay? So you've got 2 plus 22, 24 computers connected to this hub. Okay, so what happens is, instead of connecting all the computers to the single central device, right, what we're doing is we're sending it all through this hub, and their server is also connected to this hub. Then what happens is this hub is displayed as a daisy chain, so 24 connections are going in here plus the server, and then only one connection is coming out of this hub to go into a switch of multiple ports. Okay, so you can see the powerfulness behind all of that is, instead of all of the 24 computers connecting into the switch, all of these 24 into the switch, etc., there's a hub set aside for all the computers to connect to, and then one lead connecting all of those devices into the switch. Okay, so the switch will most likely be it is the most powerful and expensive device in order to support all the computers that ultimately connect to it. You can regard the individual hubs as devices that allow connectivity for a single department in a company, or perhaps an individual classroom in a school. Okay, so you can see this may be classroom A, classroom B, classroom C. Okay, and they're all connected in that might have 24 computers in each classroom that connect all of those computers into one hub that's assigned to their configuration, which in turn is connecting, or it's configured to connect to the switch with one cable. Okay, so the master switch at the top of the hierarchy tree excuse me, connects everything together. However, it also acts as a single point of failure, which we'll address obviously as we go through the book. I will make reference to single point of failure. So obviously, if this switch goes down, everything else that's attached to it is also affected. Okay. As you guessed, this type of network architecture is the kind required to accomplish the goal laid out in the scenario in the beginning of the lesson, okay, which is the different types of networks that can be set up: basic, intermediate, and advanced. Okay, so let's move on to the next slide. Okay, so the next slide is your network adapter. Okay, so all of you, I'm sure, have seen a network adapter, and this is the device that you use to connect your Ethernet port, okay, which is your RJ45 lead or cable into the network adapter, okay, if you're using wired cables that allow you to connect onto the internet, with providing you have internet access. Okay, so the network card is also, or the network adapter is also referred to as the network interface card, and this device enables you to send and receive data to and from the computer. This adapter might be integrated into a motherboard, or act as a separate device that connects to a PCI slot, or it might have a PCI card slot or a USB port. Okay, so the adapter can connect to the network by cable, as I already mentioned, or by wireless, or by air, which is wirelessly. It has its own basic CPU to process transmitted data, as well as a ROM chip to store information about itself. So network adapters also have the software component called a driver, and I mentioned that the driver sometimes can have updates needed, so that's something that you maybe can check, that is your driver up to date. Okay, and I'll show you, we'll be accessing the network adapter properties, so I'll show you where that is. So that's something with maybe that there might be some updates in relation to the network card that's in there. So by updating the driver, you obviously get the latest software fixes or whatever you need to be installed for your network adapter card. Okay, this usually includes, this information is usually included on the properties page, which we're going to look at in a few minutes. Okay, so network adapters also have a software component known as a driver, okay, which I mentioned that. So this info is included in the properties page, okay, that we're going to look at. So I'm referencing now from page 5 to page 9 on the ebook, okay, that you can check that out and follow it as I go along. So what I'm going to do is I'm actually going to go into the start menu, and I'm going to go through the properties. Okay, I'm going to look at the network adapter in there. Okay, so I'm going to go Start. I'm going to go My Computer. I'm going to right click and I'm going to go Manage. Okay, so in here, let me just enlarge this. Okay, so in here we have your different computer management tools. Okay, so the one we want to look at is the Device Manager. Okay, so these are all the different devices that are configured and can be changed or installed, etc. on the computer, the existing computer that you're on. So where we want to go is we want to go to the network adapters section. So we expand it, and here I can see I have a Broadcom Net Extreme Gigabit Ethernet connection. So you can see that it's green, which means I'm active and I'm online. Okay, if it was a thing that was red, or maybe you might have a setup configuration where you might have a couple of network adapters set up, you might have one or two that are green and one that is red. Okay, so if it's red, obviously it's not connected to the internet, and that's where you would need to diagnose it and figure out why it's not connected. Okay, so in here what we're going to do is we're going to look at the properties. So I just right click to select properties. Okay, and I'm going to go to, there's your driver. Okay, I mentioned that earlier. So in here you can actually update your driver software to make sure you have the latest software for your driver, okay, for your card. So if I go back to advanced here, what I'm interested for today's session is I'm interested for the speed and duplex. Okay, so what this really means is mine is set to auto. Okay, so you have 10 megabits full duplex, you've got 10 megabits half duplex, 100 megabits full, and 100 megabits half, and then you have auto. Okay, so what we want to do here is mine's just selected to auto. Okay, that's just the way mine is set up. And what this really means is if you had it connected or set up to be 10 megabits full, okay, what that full stands for is full duplex. And what full duplex means is that the network card can send and receive data simultaneously obviously at the speed of 10 megabits per second. Okay, what we can do is we can select half, so you've got 10 megabits per second at half duplex. And what half duplex means is that the network adapter will send and receive data but not at the same time. Okay, so obviously, as you can imagine, the higher the speed and have it at full duplex. Okay, so full duplex is the superior connection, as long as your central connecting device that you are on fully supports it. Okay, so full duplex connection can transceive, which means it can transmit and receive twice as much per second as half duplex connections can. So to meet the requirements of, say, the scenario that we were just talking about previous to this in the advanced LAN, okay, you probably want our clients' computers to connect at 1 gigabit per second, as well as having utilized full duplex negotiation. Okay, so hopefully that might give you a little bit of insight into that. So I'll go back to auto and leave it. Okay, so that just gives you a little bit of information about the network adapter that we have. Okay, so the next section, what we're going to look at is we're going to look at the properties page. Okay, so to do that, we'll menu. We're going to go to Control Panel. We're going to go to Network and Internet, and we are going to go to Network and Sharing Center. Okay, so this is my basic network here. Okay, so this is my computer. This is the network I'm connected to, cits.local. Okay, and then this is my internet out there. So as I said, once you leave this section, my computer within the network, okay, this is considered a LAN setup here, for example. And once I leave this and go out and I access the internet, I have left the LAN section and I'm moving out into the internet. Okay, so you can see if it's a thing that you're not connected, say, to the network, there's usually a next, usually it's red, a next that would be across that line, or I might have it here, which means my network actually has no connection to the internet. Okay, so that's something you might have seen somewhere along the way in relation to you connecting to the internet. So what I want to do is I want to change adapter settings. Okay, so here's my LAN. Alright, so you can actually change the name of the LAN if you wish. I'm going to right click and I can go rename. Okay, and I can call it whatever I want. Okay, whatever name you decide. But obviously you have to take note that that is the name of your LAN. Okay, so let's go to properties. Actually, I want to double click on it. Sorry, double click is what I wanted to do. Okay, so in here I have general information about the status of my LAN. Okay, so for example, sorry, I don't know, is the microphone okay there? Okay, let me just pause this. I just want to make resume. Okay, I hope I haven't lost any audio there. I don't know why. I think I might have. Okay. Alright, so what we have here is we have the internet connection, okay, my LAN connection out to the internet. So you see IPv4, which is my internet. I'm using Internet Protocol version 4 connectivity, so you can see I'm connected to the internet. For IP version 6, I'm not connected. I don't have any internet access, okay, and the difference between those two, and I'll discuss this when we talk about protocols in future lectures. But with this, what this means is IP version 4 is running out of IP addresses, okay, so they're your 10.2.1.12, whatever it may be. They're actually becoming, they're hard to create, or I guess they're running out of IP addresses. So what they're doing is they've created this IP version 6. So what that does is that even broadens the unique IP address that you have, just to increase the amount of, I guess, traffic and IP addresses that really are out there on the internet. So we'll have a look at them when I click on the details. Okay, so the media state, you can see there that I'm enabled. Okay, the duration, it's 3. Oh yeah, so I'm up 3 hours and 50 minutes. So that's how long I'm up connected to the internet, and my speed is 1 gigabit per second. Down here in my activity section, I have the amount of bytes that I'm sending and receiving. Okay, so you can see them there, and that you can see that they're constantly changing. So if I click on the details, okay, so here you have your details connection. So this is the network I'm connected to. This is the Ethernet connection. This is my physical IP address. This is my IP address there, IP version 4. Okay, so you can see that there. That's my subnet. Let me see what else you have. Your IP version 6. Okay, so that's a completely different number and looks very different to your IP address, IPv4. Okay, you've got your DNS server IP address, your DHCP server, your default gateway, etc. Okay, so all that information is in there. And just while I have that window up, I'm just going to run a command line. Okay, and I'm just going to do an IP config on my computer just to see, so I can verify there that my IP address is the same as it's given there. Okay, alright, so that is in your details section. Okay, so then what you also have is you also have your disable button. So if I was to click on disable, what I would do is I would actually cut my internet connection here, and I would no longer be connected to the network. Okay, I can also diagnose any problems that I might have. So if I don't have any internet connection, by clicking on the diagnose button, you run a lot of background programs to try and see why you're not connected to the internet. Usually you might see that maybe if you're on the bottom right hand corner here, when you're not connected to the internet, it says diagnose this problem. Okay, so that's the area you're talking about there. So if I click on properties, okay, in here I can select my internet, my TCP/IP version 4 protocol. So I can click on that. Okay, double click, and in here mine is set to obtain an IP address automatically. I can use it to configure if I wanted my own IP address and subnet mask, etc. if I wanted to give it details, but I don't, so I'm not going to change it. Okay. Okay, so that's just a little bit of information about your LAN and its properties. Okay. Alright, so I've gone through this. Okay, the speed of the network adapter, I've gone through this. Okay. Now let's look at the LAN. Okay, the LAN properties, again, I went into the control panel, internet, network and internet, etc. So I've gone through all the information that's in there. And I just made a note here that the network adapter is only as fast as the network it connects to. Okay, so that's just something to bear in mind. Okay, so what we have here is identifying types of LANs. Okay, there are several types of LANs that computers can connect to. An organization must choose whether they want to use wired connections or wireless connections, or a mix of both. Okay, so this is just a diagram that I've taken from the book. Right, I've referenced there page 15 of the ebook, and it shows you an example of a wired LAN. Okay, so I'm just going to go to page 15 on the book. Okay, so I think I've mentioned this on the next slide. Yeah, okay, so you can actually look at the diagram as I just read through this on page 14. Okay, so what we have here is we have computers and other devices that are wired together, okay, and they're using copper-based twisted pair cabling. These cables have RJ45 plugs on each end, okay, which make the actual connections to the RJ45 ports that reside on the computer's network adapter, hubs, switches, routers. Okay, so here you would have your router here, your hubs here. So all these connections, or all these, the communication here, are all into RJ45 port holes, okay, that the devices connect into. Okay, so what this diagram does is it just gives you an example of three LANs connected together by a router. Okay, so here's the router. So a few more devices we haven't seen until now are shown in this figure, namely a firewall, okay, which is here, which protects the LAN or the LANs from the internet. You've got a supercomputer here, which occupies its own LAN, okay, that can be set up. Okay, so generally the connection from the PC to their switch will either use 100 megabits per second or 1 gigabit per second. Whatever speed you decide to use, it must be able to support it by the switch, okay, as well as by each computer that is attached to the hub and the switch. Okay, so they all have to be able to support the speed that you've decided to configure or set up. So in order to, I guess, have this speed of 1 gigabit per second, that it's recommended that you need to use cables that have category 5E or greater. Okay, so if you remember back to our cabling tutorial, you would have saw that there was category 1, 3, 5, 5E and 6. Okay, so it's talking about category 5E or greater, which obviously is quite expensive to purchase, but that's what you need to have the speed of 1 gigabit per second. Okay, so the connection from the server farm, okay, which is here, to the switch in this section here, as well as the connection from this supercomputer to the switch, should be faster than the average PC connection. So if the PCs on the LAN down here are at 100 megabits per second, okay, the server might be better off connecting at 1 gigabit per second. Okay, so similarly, if the PCs are connected at 1 gigabit per second, the servers should be connected at 10 gigabits per second. So it's just increasing the speed. Okay, so for example, I'll just kind of explain that again. So if these PCs here are operating at 100 megabits per second, okay, then this server should be 1 gigabit. But if you want these computers here to be 1 gigabit per second, then you want the server to be 10 gigabits per second. Okay, so high-speed connections high-speed connections should also be made between the 3 switches and the router. Okay, so again, it should be rolled out that these switches here are all 10 gigabits per second as well. Okay, so now we are looking at a more accurate representation of a network setup for an example of I suppose a fictitious company example here that we have on this. Okay, so I guess as you look at more complex LAN setups, okay, you can appreciate why switches and routers, I guess, were invented or created. Okay, just to be able to have advanced hierarchy setups. Okay, so I've kind of mentioned this in my previous slide. Okay, so it uses copper-based twisted pair cabling. they're RJ45 plugs, okay. You've got a firewall, okay, which if I made reference to here. Here's the firewall, okay, which is outside the network. This connects to the internet. So once you leave this router and you connect to the firewall, and the firewall then connects out to the internet. Once outside, so say the right hand side of this firewall, you have left the LAN network and now you are out into the internet network, so to say. Okay, so you have left the LAN at this point. So inside it is the router connected to the firewall. You're still within the LAN here, but outside this you are connected to the internet and outside of the LAN. Okay, so significantly faster. Okay, so wired LANs are significantly faster than wireless, but wireless LANs are catching up. Okay. Okay, so now let's talk about a wireless LAN, okay, which is a WLAN. So a wireless local area network, okay, or I'll call it a wireless LAN, is a flexible data communication system implemented as an extension to or as an alternative to a wired LAN. Okay, so a wireless LAN uses radio frequencies, okay, to transmit the wireless data and to receive it over the air, minimizing the need for wired connections. Therefore, wireless LANs combine broadband data connectivity to user mobility. So really what that's saying there is it uses radio frequencies, okay, over the air to transmit and receive data. What it also does is it allows connectivity for a user to be mobile when connecting to the internet. Okay, so the whole idea there is about the ability to roam. So more and more devices are becoming wireless, on the go, easy to use, I guess not stationary. So examples would be laptops, PDAs, mobile phones and tablets. Okay. However, wireless LANs can pose security problems when it comes to companies who do not wish to use them. Okay, or who do not wish to use them. Okay, so I'm in reference to the book. We're still on page 15 here, and this is a picture I've taken from the diagram or from the book that just shows you a wireless access point, okay, that's transmitting a wireless signal to all the devices within a certain area. Okay, so with the wireless, okay, or it's also referred to as the WAP, okay, WAP, it acts as a central connecting device for the network. So such networks can consist of many types of devices other than traditional PCs, okay, so as I mentioned they can include mobile phone, PDAs, tablets, etc. Not to mention the fact that PCs and laptops are equipped with wireless network adapters, so they can also connect to the networks as well. Wireless networks and wired networks can actually be used together. Okay, so in small companies, a single device can act as a wireless access point, a switch, a router, or a firewall. Okay, so however, large networks will usually have one or more separate wireless access points that connects to a wired fashion on a network switch. So really what it's saying there is you have multiple WAPs. So say you're within kind of one building, but big enough building, maybe, I don't know, 4 or 5 stories high, and you would, because obviously you might be moving around the building and you are connected to the internet via wirelessly. As you roam around the building, what it's really saying is that there's multiple wireless access points, so that your signal or your connection never breaks. So whether you go from floor 1 to floor 3, from one end of the building to the other, you still should have full wireless connection to the internet. Okay. Or not even to the internet, yeah, to the internet, yeah. Okay, so the next one we're going to talk about, okay, these are just points I would have mentioned. Wireless access point acts as a central connecting device, okay. So there are many different types, as well as PCs, tablets. Okay, so I've just talked about that. Okay, so the next one we're going to look at is virtual LAN, okay, your VLAN. And this is on page 15, page 16 of your book, okay. So a virtual LAN is a group of hosts with a common set of requirements that communicate as if they are connected together in a normal fashion on one switch, regardless of their physical location. Okay. Okay, so the VLAN is implemented to segment a network. Okay, so it's just to divide networks. So this might be an example of a school. Okay, so you've got classroom 1, 2, 3, a library and staff, or a college, whatever it may be. And the idea of setting up a VLAN is to segment the different groups of computers that will all eventually connect into the one switch. Okay, and the idea of doing this is that it, first of all, it segments the network. Okay, so it can be managed easier. It can reduce collision. It can organize the network better. It can boost performance and increase security. Switches usually control the VLAN. Okay, so you see up here there's the VLAN switch. Like subnetting, a VLAN compartmentalizes a network and can isolate traffic. Okay, but unlike subnetting, a VLAN can be used up in a physical manner. For example, or in this example here, we have a port-based VLAN. Okay, so what this does is it shows you, for example, classroom 2 here. It has its own VLAN, so everything really inside this box. So you've got 5 boxes across the way here, so everything inside this box is kind of seen as its own individual VLAN, and it has its dedicated IP address that's connected into the switch. Okay, so however the computers are connected in the VLAN, or how they are located in the building, it doesn't really matter. Okay, it doesn't really matter how they're physically connected, but the way they're networked is that they're connected to a VLAN switch. Okay, which is seen as kind of the main focal point of where it wants to get its communication to. Another example would be computers on the VLAN staff area here. Okay, so this could be located in several physical areas in the building. Okay, so say you might have staff on 4 or 5 different levels. Okay, but regardless of where they're located, because they are associated with the VLAN, with the staff VLAN, I suppose, label on it, it's a physical port which they are connected to, in turn connects to the VLAN switch. Okay, so because they're categorized under that umbrella of the staff, they will physically be connected to the VLAN switch, which in turn connects out to whatever device is connected after the VLAN switch. Okay, so whether you're out to the internet, whether it obviously goes through a firewall first, etc. Okay, so this is really just an example of a virtual LAN. Okay, so the last section we're going to talk about is the perimeter, or the DMZ networks. Okay, so in computer security, a DMZ, or a demilitarized zone, sometimes referred to as a perimeter network, is a local or logical subnetwork that contains and exposes an organization's external facing services to a larger and untrusted network, which is usually the internet. So really what it's saying is a DMZ is a physical or logical subnetwork that does connect to an external service, which is the internet. The purpose of a DMZ is to add an additional layer of security to the organization's LAN. An external attacker only has direct access to equipment in the DMZ, rather than any other part of the network. Okay, so for example, perimeter networks are small networks that usually consist of only a few servers that are accessible from the internet in some way. They are set up separately from the computer, private LAN and the internet. Okay, so it will become more clear when we look at the diagram. Okay, so this is just a note I made on a previous slide, on slide 10. I just said the extranet. Okay, if you remember the extranet, which is a connection outside of the intranet. Okay, so it allows the likes of service providers or vendors to connect to the intranet. Okay, so the extranet allows service providers to connect to the intranet through authentication and authorization. Okay, but the extranet sits outside the LAN. Okay, so the extranet is similar to the DMZ, okay, in that it provides access to needed services for channel partners without granting them access to the full entire network of the organization. So generally the term perimeter network is in relation to demilitarized zone, okay. It's called a perimeter network because it's usually on the edge of the LAN. However, when a DMZ is set up properly, those users are blocked from gaining access to the computer LAN. Okay, so we're going to look at two examples or two configuration examples of a DMZ. Alright. So users on a LAN will quite often connect to a DMZ as well, but they can do so without having to worry about outside hackers gaining access to their private LAN. A DMZ might house a switch with servers connected to it that offer web, email and other services. Okay, so those services are, I guess, housed, or they're accessed using the DMZ setup configuration. Okay, so let's look at the two examples that we have. We've got back-to-back configuration and you've got a 3-leg perimeter configuration. So this might make it a bit more easier to understand. Okay, so here we've got the back-to-back configuration. So what we have is we've got the DMZ is situated between the two firewalls. Okay, so here we have your LAN set up, okay, and we've one firewall. Here we have another LAN set up here, okay, and we've got your email and your web. But this is seen as your DMZ, okay, and then you've got your firewall, and then you've got your internet. So what it's saying is the DMZ is situated here, okay, between two firewalls. So if a hacker was to get through to your LAN network, it would have to gain access to both firewalls, okay, in order to get in. So there's good configuration and good setup. This would be a hard configuration for a hacker to get through, okay. So let's compare it to the 3-leg DMZ configuration. Okay, so what we have here is, again, we have your LAN. Okay, so that's connected to your switch, for example. That has a firewall, and then you go out to the internet. Or if you go this way, you've got your DMZ that's connected to a web server, a mail server, whatever it may be. So what happens is the DMZ is usually attached to a separate connection of the computer, of the company firewall. Okay, so here's the firewall here. So the firewall has 3 connections. One that's going to the company LAN, which is here with the 3 PCs connected to the switch. The other one that has got that's connected to the DMZ with the web server and the mail server off that. And then you've got one that's connected out to the internet. So an attacker would only need to break through one firewall, okay, to gain access to the LAN. So while it is a disadvantage, okay, for intrusions, another way to look at it is it really comes in here. If it gets through the firewall, really all the information that it might access would just be on the web server or mail server, for example. So sometimes you might have emails where there might be bugs attached to it, or trojans, or whatever they might be when you open up emails, or if you're on a website, or you might have clicked a button you shouldn't have and it spirals off into a load more web pages or stuff like that. You're I guess a bit more vulnerable when things like that happen. So because these servers are out here connected to the DMZ, and hackers might be able to get at the servers in here, it's kind of a sidetrack way of configuration where they'll go through this channel and connect onto the web servers, as opposed to getting access into the internal LAN here. Okay, and obviously with there's only having one firewall, there's less administration with that. Okay, all right. So the DMZ, okay, so any services that is being provided to users on an external network can be placed on the DMZ. The most common of these are web servers, mail servers, FTP servers, and voice over IP, okay, servers. So web servers can communicate with an internal database that require access to the database server. which may not be publicly accessible and may contain sensitive information. The web server can communicate with the database servers either directly or through an application firewall for security reasons. Okay, so there's not really a direct link. It will have to go through security procedures before it will gain access into the LAN, okay, from outside the DMZ. So email messages, and particularly the user database, are confidential. So they are typically stored on servers that cannot be accessed from the internet, okay, but can be accessed from email servers that are exposed to the internet. So again, depending on the setup that you might have, you know, if it accesses your database, and that obviously has confidential information, again, you might use a security protocol or security setup, an extra firewall configuration in order to prevent attackers on the network. Okay, the mail server inside the DMZ passes incoming mail to the secured or internal mail servers, okay, and it also can handle outgoing mail. So again, when you're in the DMZ, for example, when you have your web and your mail, when you're at the DMZ server, in order to get access back into the LAN here, the firewall has a lot of securities and policies set up in place. Okay, so this is still seen as an internal network. However, you're going through a different route to get to the LAN. Okay, so again, it really depends how the network is configured and set up. Okay, so the last slide here is just to remind you of the different resources, and I just wanted to put this slide up just to make sure that you all have got your ebook, that you've accessed LearnKey and used each of the chapters in there along with your book, that you also have access to MeasureUp, okay, so that you've logged in and used it as a resource as well as testing your knowledge to get you exam ready. To remind you to do some web browsing or YouTube browsing, for example, to see videos of different types of, I guess, content that's in the book, for example, OSI models, topologies, LANs, WANs, whatever it might be, okay, because there are some good videos out there and some good people who've put up kind of quick summary videos that might just, you know, be the missing puzzle bit to kind of your questions in relation to some of the content on the course. Okay, so obviously the live lectures is set up on a weekly basis to help and aid you with your study. Also, if it's a thing that you come across some useful web links as you're browsing or looking for content or whatever it might be, to put them up in the course forums on the main networking page, just to share them with the rest of the students, because it's good to share and it's informative for the rest of the students. Okay, and obviously if you have any questions, you just pop me an email or ask obviously within the lectures. Okay, alright guys, thanks very much and talk to you soon.